Good evening, children.
Good evening, ma'am.
Good evening, ma'am.
Good evening. So I didn't. I just found that I was on mute, children. I'm sorry. Yes, children. This is the first question. Tell me, how do we solve this?
Ma'am, identity.
Yeah. What's identity?
Sign.
No. You tell me the algebraic identity.
Ma'am, A plus B into A square plus AB plus B square, ma'am.
No, you're right. A plus B into A square minus AB plus B square is equal to what? Is equal to?
A cube, B cube, ma'am. A cube plus B cube, ma'am.
A cube plus B cube. So A cube plus B cube is equal to A plus B. So this cos cube theta plus sin cube theta is like A cube plus B cube. So A is cos theta and B is sin theta. So A cube plus B cube is A plus B. A plus B. So A is cos theta, B is sin theta. A plus B into A squared. A squared minus AB minus cos theta sin theta plus B square plus sin square theta. There'll be no place, so let me just write it again. A plus B, so cos theta plus sin theta into A square cos square theta minus AB cos theta sin theta plus B square plus sin square theta divided by whatever we have there, cos theta plus sin theta. And you can see this gets cancelled. Plus A cube minus B cube is A minus B into a square plus ab plus ab plus b square divided by cos theta minus sin theta. So this gets cancelled. So in the numerator, you can see cos square theta plus sin square theta. It's 1. Or maybe you can write it like this in the next step. So sin square theta plus cos square theta minus cos theta sin theta plus sin square theta plus cos square theta plus cos theta sin theta. Cos theta sin theta. So this gets cancelled. Minus cos theta sin theta plus cos theta sin theta. So this one is 1, 1, and this one is 1, 1 plus 1, which is 2. And that's the RHS, hence proved. So if you don't know this algebraic identity, you will not be able to solve it. Done, children?
Ma'am, no, ma'am.
Okay. Yeah, done, children? Yes, no. Yeah. So the identities are very important. A plus b into a square minus ab plus b square is a cubed plus b cubed. A minus b into a square plus ab plus b square is a cubed minus b cubed. So these are the two algebraic identities which were used to solve this trigonometric identity. Same heading, children. Prove the trigonometric identity. 1 plus sin theta minus cos theta by 1 plus sin theta plus cos theta. The whole square is equal to 1 minus cos theta divided by 1 plus cos theta. All right. So the numerator and the denominator, both of them, the numerator and the denominator has 3 terms. you can see that, the three terms are sine theta, cos theta, and 1. And I've told you when the numerator and denominator is made up of sine theta, cos theta, and 1, divide the numerator and denominator by sine theta or by cos theta. But here you can see the fraction is squared or that expression is squared. So we'll apply the square. We'll not do that. I have told you that when, one side of the identity is made up of sine theta, cos theta, and 1. That is the numerator and the denominator. Then you should divide the numerator and denominator either by sine theta or by cos theta. Here we are not doing that. I'm giving you the reason for that. Because the expression is squared. So let's square the numerator and square the denominator. The numerator has 3 terms. The denominator also has 3 terms, which means to square this, we need to use the identity a plus b plus c the whole square. Now, what is a plus b plus c the whole square? What is a plus b plus c the whole square? Tell me. What is a plus b plus c the whole square? A square plus b square plus c square plus 2ab plus 2bc plus 2ca. Make a note of this. 9th standard. A square plus b square plus c square plus 2ab plus 2bc plus 2ca. All right. So now let's take up the LHS and square the numerator and square the denominator. LHS is equal to 1 plus sine theta minus cos theta divided by 1 plus sine theta plus cos theta, the whole square, is equal to a square plus b square plus c square plus minus cos theta the whole square, because the identity is a plus b plus c the whole square. But here it is a plus b minus c. So we should take c as minus cos theta. The identity is a plus b plus c. But here it's minus cos theta. So c is minus cos theta. A square plus b square plus c square plus 2ab, 2 into 1 into sine theta, plus 2bc, 2 into sine theta into minus cos theta, plus 2ca, plus 2 into minus cos theta into 1, divided by same thing, a square plus b square plus c square plus 2ab plus 2bc plus 2ca cos theta into 1. So that gives us 1 plus sine square theta plus cos square theta, because minus cos theta into minus cos theta is plus cos square theta, plus 2 sine theta plus 2, oh sorry, minus, because there's a minus in the bracket there. Minus 2 sine theta cos theta minus 2 cos theta divided by 1 plus sine square theta plus cos square theta plus 2 sine theta plus 2 sine theta cos theta plus 2 cos theta. Now what next, children? Please tell me.
Sine square theta plus cos square theta 1.
Very good, Ram. Very good. Sine square theta plus cos square theta is 1. Denominator also sine square theta plus cos square theta is 1. So 1 plus 1. Children, I'm repeatedly getting some calls. I don't know who it is. Just a minute. Yes, children, 1 plus 1 plus in the numerator we have 2, so write the other terms as they are. 2 sine theta minus 2, because you don't find like terms to simplify. So you just have to write them as they are. Or children, just to save time, you can, all right, fine. So 1 plus 1 plus 2 sine theta plus 2 sine theta cos theta plus 2 cos theta. Then next step, 1 plus 1 is 2. 1 plus 1 is 2. So again, write all the other terms as they are. Yeah. Now what will be the next step, children? It's okay if you have not written in your book. What will be the next step? Tell me, quick.
Common 2.
Very good, Taran Murali. Very good. Taking 2 as the common factor. Very good. The 2 is common in both the numerator and the denominator. 2 is common in both the numerator and the denominator. Can somebody tell me 2 into what? Taran Murali, 2 into 1 plus 1.
I did not wrote, ma'am.
Oh, right. Okay, sorry. So sine theta minus sine theta cos theta minus cos theta plus sine theta minus sine theta cos theta minus cos theta divided by 2 into the same terms. I'll just check if the signs are correct. Sine theta minus sine theta cos theta minus cos theta. Sine theta minus, yeah, I'm right. Yes. So after taking 2 common, this is what we get in the numerator and the denominator. Now next what? Next?
2 to cancel.
Yeah, 2 you can cancel out 2 in the numerator and the denominator. Very good. Now how many terms do we have in the numerator and denominator? How many terms? How many terms are there in the numerator?
4, ma'am.
4. What do we normally do? When we have 4 terms, what do we normally do when we have 4 terms? Ninth standard, 8th, 9th standard. 4 terms. Supposing you have to factorize an expression which has 4 times, what do you normally do? No, that's for a quadratic expression, splitting the middle term. In algebra, when we have to factorize an expression with 4 terms, generally, I'm not saying always, 80% of the time you have to do something. When there are 4 terms, you'll have to group. You'll have to group the first 2 terms and the last 2 terms, or maybe you can change the order of the terms and group them. So here you can group it as it is. So you can group 1 plus sine theta. That is, they have 1 common. 1 is common. 1 and sine theta, what is common? 1 is common. Don't forget to write that 1. You will make a big blunder otherwise. See, the first two terms are 1 and sine theta. What is common between 1 and sine theta? Nothing is common. That means 1 is common. 1. So write 1 outside. 1 into 1 is 1. 1 into sine theta is sine theta. Then minus between the third and the fourth terms, cos theta is common. Minus cos theta. So in the bracket, you will get sine theta. Minus into plus is minus 1. Divided by, same thing. 1 is common. Between the first two terms, 1 is common. Into 1 plus sine theta plus cos theta. Between the third and fourth terms, cos theta is common. So sine theta plus 1. So what do we do after grouping? Whatever we have in the bracket, we write it once. In the bracket, we have 1 plus sine theta. This is sine theta plus 1, but both are the same. In the brackets, we have 1 plus sine theta and sine theta plus 1. Both are the same. So write that once, 1 plus sine theta. And then this 1 minus cos theta in the other bracket, 1 minus cos theta in the other bracket, divided by, again, in the brackets, we have 1 plus sine theta plus 1. They're the same. So write it once, 1 plus sine theta. And then in the next bracket, 1 plus cos theta, 1 plus cos theta. Oh, sorry. 1 plus cos theta. So now we get 1 minus cos theta divided by 1 plus cos theta. But on the LHS, on the RHS, we have something else. On the RHS, we don't have this. We have something else in the RHS. So we'll work the RHS. Okay, RHS is equal to root of, oh, that's a different question. Oh my God, this is the RHS. I'm sorry. I was looking to another question. This is the RHS, hence proved. Yeah, children, please write down. One minute. Yes, children, right. Done, children?
Yes, ma'am.
All right. Next one, children, very interesting one. To see how much we use algebraic identities to solve trigonometric identities. We use them very extensively here. See the next one. Secant square A plus secant square A into secant square B. All right, children. So take up the LHS. LHS is equal to 1 plus tan A. Not be plus tan B. 1 minute. It's not into plus, children. It should be tan A tan B. Just a minute. Don't erase anything. I'll write it clearly again, children. Just a minute. 1 plus tan A tan B, it is tan A tan B. 1 plus tan A tan B the whole square plus tan A minus tan B the whole square is equal to secant square A into secant square B. All right, children, let's take up the LHS. 1 plus tan A tan B the whole square plus tan A minus tan B the whole square. So you just have to use identity. A plus B the whole square is A square plus 2 into A into B, 2 into 1 into tan A tan B, tan A tan B. Okay, plus B square, tan A tan B the whole square, tan A tan B whole square. Then again A minus B the whole square is A square, tan A the whole square minus 2 tan A into tan B, 2AB, 2AB. So 2 into tan A into tan B. This is 2AB, children, plus B square, same line, continue the same line, plus B square, plus tan B the whole square. I don't have place, I've written it below. A square plus 2AB plus B square plus A square minus 2AB plus B square. So 1 plus 2 tan A tan B plus tan square A tan square B, tan square A tan square B plus tan square A minus 2 tan A tan B minus 2 tan A tan B plus tan square B plus tan square B. Now you can see here plus, you can see this one here, plus 2 tan A tan B minus 2 tan A tan B gets cancelled. So what are the remaining terms? We have 1 plus tan square A tan square B plus tan square A plus tan square B. Now again, how many terms we have, children? How many terms?
4, ma'am.
4 terms. So what should you do?
Factorization.
Grouping, yeah. So like how we factorize by grouping, should do the same thing here. Now you see that there is nothing common between the first and second term and nothing common between the third and fourth term also. So you have to rearrange. Because first and second term, one is common. Third and fourth term also only one is common. Then you will get the same thing. You cannot factorize it like that. So just rearrange the terms. Tell me, what should I do? Anything. You can write 1 plus tan square A or tan. Yeah, tan square A or tan square B here. Anything you can write here. One end you can write tan square A or tan square B. Then write tan square A, tan square B plus tan square B. Correct. So between the first and second term, only 1 is common. Between the third and fourth term, tan square B is common. So you will get tan square A plus 1. So in the bracket, we have the same thing, tan square A plus 1, tan square A plus 1. Or you can write anything, 1 plus tan square A or tan square A plus 1, anything you can write. Both are the same, into 1 plus tan square B, into 1 plus tan square B. Now 1 plus tan square A is secant square A and 1 plus tan square B. You can see it's a multiplication. So secant square A is secant square B, because secant square A minus tan square A is 1. Secant square B minus tan square B is 1. So 1 plus tan square A is secant square A. 1 plus tan square B is secant square B, which is clearly the RHS. Yeah. Please write down, children.
Ma'am, can you repeat the first 2 lines, ma'am?
Okay, can you just work it first, Sneha, Harini? I'll definitely do it. I'll work it again, I meant. I want to write it and explain. So you first write down the whole thing. I'll write and teach you again. All right?
Yes, ma'am.
Yeah.
Completed, ma'am.
Yeah. All right. All right, let me work it again. So in the first bracket we have 1, I forgot, 1 plus tan A tan B, I think. Yeah, 1 plus tan A tan B, the whole square, plus in the other bracket tan A minus tan B, the whole square. So here this is the A term, this is A and this is B, this one is B. Here like this is X and this one is Y. So A plus B the whole square. The first bracket is A plus B the whole square. A square plus 2AB, 2 into A into B is tan A tan B. B is tan A tan B. 2AB plus B square. This is B. This one, see, this one is B and B square. Now, when you work this, you will get, when you simplify this, you will get 1 plus 2 tan A tan B, 2 tan A tan B plus tan square A, like AB the whole square is A square B square. Similarly, here it will be tan square A into tan square B. Tan square A into tan square B. This is about the first bracket. The second bracket is tan A minus tan B, the whole square. This one is like x minus y the whole square. So x square, tan A the whole square, minus 2xy, 2 into x, tan A, into y, tan B, plus y square, tan B the whole square. Is it okay?
Yes, ma'am. Yes, ma'am.
Yeah.
Thank you.
Yeah, welcome. Further, you were able to understand?
Yes, ma'am.
Okay. I think because it was tan A, tan B, you had a little doubt there. Okay. Any questions, children? Anything else?
No, ma'am.
All right. Tan A secant A minus cot A cosecant A minus cot A cosecant A. 1 plus cot A plus tan A into oh my God, what am I? 1 plus cot A plus tan A into sin A minus cos A is equal. Oh my God, I'm messing up, you know. I'm sorry. The RHS is not correct. One plus cot A plus tan A into sin A minus cos A is equal to yeah, secant A by cosecant square A minus cosecant A by secant square. All right, yeah, now I'm right now. Ready, children?
Ma'am.
Yes. Yes, Harini?
Ma'am, no, ma'am.
Okay. All right, children. So what do we know? We know that when we have other ratios, we can convert them to sine and cos. So let's use that rule and get started. Just write out the LHS first. Sine A minus cos A. Yeah, this is the left hand side. So let's use that rule. So 1 plus cot A is cos A by sine A plus tan A sine A by cos A. And the other bracket, nothing can be done. So sine A minus cos A as it is. Next step, LCM. Sine A cos A is the common denominator. Sine A cos A. So you get sine A cos A plus cos square A plus sine square A. Sine square A into sine A minus cos A into sine A minus cos A. All right, so that's equal to in the new. Okay, now this is very important. Now don't change, don't write sine square A plus cos square A as 1. Do not write sine square A plus cos square A as 1. Now see here, when you multiply the numerators, you get sine A minus cos A into sine square A plus sine A cos A plus cos square A divided by sine A cos A. Just tell me if you can understand this. You'll have to multiply the numerators and multiply the denominators. Multiply the numerators. So I've written sine A minus cos A first. So sine A minus cos A into, I've just rearranged for some reason. I've written sine square A and then sine A cos A and then cos square A divided by sine A cos A. See, like what will you do when you have B by C into A? You will write it as A into B by C, whole thing by C. A into B, you multiply the numerators, A into B by the whole thing by C because it's by 1 here. So C into 1 is C. So like that, it's by 1 here, by 1. Multiply the numerators, multiply the denominators. Yeah. Now tell me, children, is it clear?
Yes, ma'am.
Yeah. Now, what should I write in the numerator? What should I write in the numerator now?
A plus B the whole square.
A plus B the whole square? No, the 2AB is not there.
Okay.
Class, use the emoji. Raise your hand. Rajarajeshwari, Nandini, Tarun Murali, Ananya, Ramanathan, Sashmin, Harini, Sneha, Shreyas, Hitesh, Murali Krishna and Priyanka. Murali Krishna, Hitesh and Priyanka. Are you there? Hitesh. What about Priyanka? All right, children. I'll be happy if I get the answer from you. Look at the numerator, sine A minus cos A into sine square A.
Minus B cube, ma'am.
Yeah, A cubed minus B cubed. Because it's like A minus B, sine A minus cos A minus B, A square, sine square A sine A, B is cos A. So A square plus AB plus B square. What is A minus B into A square plus AB plus B square? A cubed minus B cubed. See, I've written above the terms. Sine A is A, cos A is B. So the first bracket is A minus B. The second bracket is A square because A is sine A. Sine square A square. Sine A cos A into B plus cos square A, B square. A minus B into A square plus AB, not 2AB. It's not 2AB, it's just AB. A minus B into A square plus AB plus B square is A cubed minus B cubed, which is nothing but sine, you can write it directly, sine cubed A. Sine cubed A cubed minus B cubed, sine cubed A minus cos cubed A divided by sine A cos A, divided by sine A cos A. Now, what is the RHS? Secant A by cosecant square A minus cosecant A by secant square A. Fine. So we'll work with this. So what you should make a note, you should put a whatever like an arrow and a star and write. Do not substitute 1. Do not write or do not substitute 1 for sine square A plus cos square A. Because that is only A square plus B square term. That is only A square plus B square term. You should not disturb that. Sine square A is A square, cos square A is B square. If you write 1, then you will not get the desired RHS. You should not do that. So that you should remember here. You should not substitute 1 for sine square A plus cos square A. Because then you'll damage the identity. You should not do that. Okay. So we have sine cubed A minus cos cubed A divided by sine A cos A. Now tell me what next? What can we do next? Quick, quick, quick. No, this is slow. We've seen this many times earlier. What can you do after this? Now again, don't write it as A minus B, A square plus AB plus B square. From there we have
Sine cube A by sine A by cos A.
Very good. Then
minus cos cube A by sine A cos A.
super, very good.
Ma'am, your screen is not visible to me. Can I leave and join?
Oh yeah, please.
Yes, ma'am.
Yeah, next what?
Ma'am, cancel sine A
And sine cubed A. So what will be left in the numerator?
sine square A by cos A.
Sine square A by cos A minus cos square A.
A by sine A.
Somewhere close to the answer we are. Very good. Yeah. Now this is, let me write it like this for you. It's sine square A divided by cos A minus cos square A divided by sine A. Now they don't want in the right hand side, you see, there is no sine and cos there. It's only secant and cosecant. So what we're going to write? We're going to write sine square A as 1 by cosecant square A. Equivalent. Sine square A is 1 by cosecant square A divided by cos A is 1 by secant A. We are writing equivalent, not the reciprocal. Sine square A can also be written as 1 by cosecant square A. Cos A can also be written as 1 by secant A. Here, cos square A can also be written as 1 by secant square A divided by sine A can also be written as 1 by cosecant A. You're writing the equivalent everywhere. We're not writing the reciprocals. I'm continuing here. So now in the first bracket, 1 by cosecant square A into secant A. Reciprocal. Division becomes multiplication. 1 by secant A is the reciprocal of that is secant A. Children, here it's because when division becomes multiplication, we write the reciprocal of the next term. The reciprocal of 1 by secant A is secant A minus 1 by secant square A, 1 by secant square A into cosecant A. This is the normal mathematical rule. Nothing to do with trigonometry. Division becomes multiplication. The next term will be written as its reciprocal. That's a mathematical rule. Nothing to do with trigonometry. That is equal to secant A secant A by cosecant square A minus cosecant A by secant square A, which is the RHS. Which is the RHS. Yeah, please start writing. Done this one, children?
Yes, ma'am.
Oh, okay.
Yes, ma'am. Done now.
All right. Done, children? Is it over, children?
Yes, ma'am.
Yeah. So is it over?
Yes, ma'am.
All right. Next one, similar to this one. 1 plus cot A plus tan A into secant A minus cosecant A is equal to tan A secant A. Tan A secant A minus cot A cosecant A minus cot A cosecant A cosecant A. Prove that 1 plus cot A plus tan A into secant A minus cosecant A is equal to tan A secant A minus cot A cosecant A. Yeah, good. So let's take up the LHS. All right, I hope we're ready. So let's use that rule, change other ratios to sine and cos. So using that rule, 1 plus cot is cos A by sine A. Tan is sine A by cos A. Change all the ratios to sine and cos. Secant is 1 by cos A minus cosecant is 1 by sine A. So this is the first step. Now this will take us to the others. So now LCM, common denominator, sine A cos A. Numerator is sine A cos A cos square A plus sine square A. Again, common denominator, sine A cos A. Sine A cos A is a common denominator. So you get sine A minus cos A. Now, again, here also do not write sine square A plus cos square A is 1. Do not do that because you will disturb the identity. So it's like we have A by C into B by C, which is nothing but A into B by C square. A by C into B by C is A into B by C square. Multiply the numerators, multiply the denominators. It's a product. So let's multiply the numerators and we'll write it in the order we want, to use the identity. So let's write sine A minus cos A first. Sine A minus cos A minus B into A square. So we choose to write sine square A first. Plus AB plus sine A cos A plus B square plus cos square A. We're just arranging the terms to suit the identity. And when you multiply the denominator, sine square A, it's not common denominator, children. Only for addition, subtraction, it's common denominator. Multiplication, multiply the numerators, multiply the denominators. Sine A into sine A, it's like AB into AB, A square, B square. Denominator is like AB into AB, A square, B square. So sine A into sine A, sine square A, cos A into cos A, cos square A, it's a product. Numerator alone, we have, written the terms in the order to suit the identity. A minus B, A square plus AB plus B square. So now the numerator is A cubed minus B cubed, sine cubed A minus cos cubed A divided by sine square A cos square A, sine square A cos square A. So the RHS is tan secant cot cosecant. Okay. Let's continue. So what do we have? We have sine cubed A minus cos cubed A divided by sine square A cos square A. So what's the next step, children?
Sin cube A by sin square A cos square A.
Yeah, very good. Sin square A cos square A. Yeah.
Minus cos
Yeah.
A
By
sin square A cos square A.
very good. Sin square A cos square A. Then what will happen?
Cancel, ma'am. Sin
Yeah,
A by
correct. So what will remain in the numerator?
sin A by cos A.
Sin A by
Cos A.
cos
A, ma'am. Cos square A.
cos square A. Yeah. Minus
Cos A by sin square A, ma'am.
cos A by sin square A. Very good. Sin square A. Very good. Now, can you see the RHS has tan and cot? See that? The RHS has tan and cot. So now we have sin and cos here. What should you write? Write sin A by, write cos square A as cos A into cos A. Minus cos A by, write sin A as sin A into sin A. Sin A into sin A. Now what is sin A by cos A?
Tan A.
Tan A. Tan A. Tan A. So tan A, and you have, what do you have actually? Tan A into, will you, okay, let me write it like this, children. 1 minute, 1 minute. No, I'll make it more clear. 1 minute. So let's write it like this. So this is equal to, in the first one, we have sin A by cos A, sin A by cos A into 1 by cos A. Let me write it like this. Minus cos A by sin A, cos A by sin A into 1 by sin A, into 1. No, I'm just trying to write it neatly. 1 minute. Same thing. Sorry. See here. So this is sin A divided by cos A. There's one more cos A in the denominator. So into 1 by cos A minus cos A by sin A. Cos A by sin A. And there is one more sin A in the denominator. So into 1 by sin A. Into 1 by sin A. Now what is sin A by cos A?
Tan A.
Tan A. What is 1 by cos A?
Secant A.
Secant A.
Secant A minus, what is cos A by sin A?
Cot A.
Cot A.
Cot A.
Cot A. 1 by sin A?
Cosecant A.
Cosecant A. And that's exactly what we have in the RHS. Is equal to RHS. Is right on, children? Done this slide, children?
Yes, ma'am.
Yeah. Yeah. Done, children? Can we go to the next one?
Ma'am, 1 minute. Ma'am.
Okay.
Ma'am, done, ma'am.
All right, children. All of you? Anyone still writing? Please tell me. Right. Yeah, this is the next one. Prove that 2 into, I think this is the sixth one. I'm not sure about the number. 2 into sine theta to the power 6 plus cos theta to the power 6 minus 3 into sine theta to the power 4 plus cos theta to the power 4 plus 1 is equal to 0. Okay, so let's take up the LHS. I would like to do it in different steps so that, I can make it very clear. So in step 1, I'm just taking up, in step 1, I'm just taking up this first part, 2 into sine theta to the power 6 plus cos theta to the power 6. Okay, so this is 2 into. Now you always want to write sine square theta. Okay, you don't want to write sine cubed theta because you know that sine square theta plus cos square theta is 1. Okay, so you know that sine square theta plus cos square theta is 1. See 2 into 3 is 6. Now you can put a 2 inside or a 3 inside, but you don't want to write sine cubed theta. You want to write sine square theta. So sine square theta, the whole cube. Don't reverse it. Don't write sine cubed theta, the whole square. Don't do that. When you write, you prefer to, write sine theta to the power 2. Because we know sine square theta plus cos square theta is 1. So we'll write the 2 inside and the 3 outside. Plus cos square theta. We are comfortable with cos square theta. So we'll put the 3 outside. So this is how we rewrite the expression. 6 is written as 2 into 3. 6 is written as, the power 6 is written as 2 into 3 with 2 inside and 3 outside. Sine square theta, cos square theta. Now this is of the form a cubed plus b cubed. A cubed plus b cubed is a plus b. A plus b into a square. What is a square? Sine theta to the power 4. A square plus ab. Not plus, minus ab. A square minus ab minus ab. So sine square theta cos square theta minus ab plus b square plus b square. So plus cos theta to the power 4. A cube plus b cube. So a is sine square theta, b is cos square theta. A is sine square theta, b is cos square theta. So a plus b into a square minus ab plus b square. So this is nothing but 2 into 1. 2 into 1. Sine square theta plus cos square theta is 1. So 2 into 1. And in the other bracket we have, sine theta to the power 4 and cos theta to the power 4. See, again, this must be simplified further. You know that a square plus b square is a plus b the whole square minus 2ab. A square plus b square. Okay, let me put it like this. We know that a square plus b square plus 2ab is equal to a plus b the whole square. A plus b the whole square. So a square plus b square is equal to a plus b the whole square minus 2ab. A square plus b square is equal to a plus b the whole square minus 2ab. So now we're going to write sine theta to the power 4 as sine square theta the whole square plus cos square theta the whole square minus sine square theta cos square theta as it is. This one as it is. So this is going to be 2 into a square plus b square is a plus b the whole square. So tell me what is a plus b the whole square, children?
A square plus
A
B
square.
square.
No, that's what. Now here I'm reading sine square theta the whole square is a square plus I'm reading cos square theta the whole square is b square. So a square plus b square is what? A plus b the whole square minus 2ab. So tell me in terms of sine and cos here. What is a plus b the whole square?
Sine square. Ma'am, sine square theta plus cos square theta.
Okay.
The whole square.
Very good. The whole square minus 2ab minus 2
Sine square theta cos square theta, ma'am.
sine square theta cos square theta. Very good. Then that's all. We have used identity, but there's one more term left, right?
Minus sine square theta cos square theta.
Minus sine square theta cos square theta. Very good. Very good. A square, children. See, this is a. Sine square theta is a, and you can see the square outside. Cos square theta is b. You can see the square outside. So a square, sine square theta is a, cos square theta is b. A square plus b square is equal to a plus b the whole square. A is sine square theta, b is cos square theta. A is a plus b the whole square. So sine square theta plus cos square theta the whole square. Minus 2ab. Minus 2 into a sine square theta, b cos square theta. So this is 2. You know that sine square theta plus cos square theta is 1. 1 square minus, this becomes 3 because they're like terms. Minus 2 sine square theta cos square theta minus sine square theta cos square theta is minus 3 sine square theta cos square theta. Now finally we have 2 into 1 minus 3 sine square theta cos square theta. On multiplying, on opening the bracket, we get 2 minus 6 sine square theta cos square theta. This is about step 1. This is about step 1. Please write down, children. Please write down. We'll wind up the session with this one, children. I'll just complete this. Done, children?
1 minute, ma'am.
All right.
Completed, ma'am.
Yeah. So now moving on to the second part, step 2. So step 2. What step there? We'll not take that sign minus, leave that. So 3 into sine theta to the power 4 plus cos theta to the power 4. That's second part. Okay, then plus 1. That's fine. So this should be written as 3 into sine squared theta, the whole square, because 2 into 2 is 4. Cos squared theta, the whole square. So again, the same identity, a squared plus b squared is equal to a plus b, the whole square, minus 2ab. Minus 2ab. So a plus b, the whole square, a sine squared theta, a sine squared theta plus b
Plus
cos
cos
squared theta.
theta.
Yeah, a plus b, the whole square, minus
2 into sine square theta cos square theta.
Very good. So what happens in the next step? What is sine?
1 whole square. 1 whole square minus 2 sine square theta cos square theta.
Correct. So this becomes 3 into
Into
One
minus 2 sine square theta cos square theta.
next.
3 minus 6 sine square theta cos square theta.
Very good. Write down till here, children, all of you. Now we'll take the LHS completely and complete the proof.
Completed, ma'am.
Yeah. So the final step. So now we'll take the LHS. Now we'll take the LHS, which is 2 and 3. Okay. 2 and 3. Plus 1. I hope I'm right. Yeah. This is the LHS, children. What is the answer we got in step 1 for the first part?
2 into 2 minus.
No, the last one. 2 minus 6 sine square theta cos square theta. 2 minus 6.
Yes, ma'am.
Yeah, sine square theta cos square theta. Yeah. This is the answer for the first part. Minus. For the second part, we got
3 minus 6 sine square theta cos square theta.
3 minus 6 sine square theta cos square theta. Plus 1. Plus 1. See, the answer for this full thing is what is down here. Minus, this minus we didn't take earlier. So minus, the answer for this full thing is what we have written in the bracket. And we've enclosed the answers in bracket because there's a minus in the middle. Plus 1. So 2 minus 6 sine square theta cos square theta minus 3 plus minus 3 plus 6 sine square theta cos square theta. Signs will change because minus into minus plus 1. Now plus and minus 6 sine square theta cos square theta gets cancelled. 2 minus 3 minus 1 plus 1 is 0. And that is the RHS. That's the RHS. So sometimes you will get this question separately also, children. They'll ask you to prove sine to the power 6, meaning sine theta to the power 6 plus cos theta to the power 6 is something. Sine theta to the power 4 plus cos theta to the power 4 is something. So it may be asked separately also. Done, children?
Yes, ma'am.
Yes, ma'am.
Right. All right, children. So that's it for today's session. Thank you. Good night.
Thank you, ma'am.
Thank you, ma'am.
Thank you, children. Good night. Thank you.
Thank you, ma'am.
Thank you. Good night.
Thank you.